Hello everyone and welcome to today's lesson. Today, we are going to talk about decimals. And the topics that we are going to learn in today's chapter are decimals, comparison of decimals, addition and subtraction of decimals, multiplication of decimals, multiplication of a decimal by a decimal, multiplication of three decimal numbers, and division of decimals. So before we get into the lesson, here is something to warm up your brain. Now, what do we know about decimals so far? We can say that decimal system is a number system that is used worldwide. A decimal means a tenth of a number. We denote a decimal by a point, and we can write a decimal as a fraction and vice versa. Now let's recall what we have learned. So, here are some decimal numbers that you have to convert into fractions. I'll help you with the first question. So, the first question is 0.9. Now, in terms of fractions, that would be 9 by 10. Similarly, we have fractions that you can convert into decimals. Here, the first question says 5 by 10. In decimal form, that would mean 0.5. A decimal number consists of a whole number and a decimal part. So, you need to circle the whole number and underline the decimal part. Now, as we know, every decimal number contains two parts, the whole number and the decimal part. So, let's circle the whole number and tick the decimal part. I'll help you with the first question. So the first question is 432.85. Here, the whole number is 432. So that's the number that we circle. Then, what comes after the decimal is the decimal part, which is 85. So that is the part we tick. So, let's start with the lesson. Now, what are decimals? Well, any fraction that has 10, 100, 1000 or so on as a denominator are called decimal fractions. For example, 4 by 10, 9 by 100, 5 by 1000, etc. are all decimal fractions. Now, 7 by 10 can be written as 0.7 and 15 5 by 10 or 15 and a half can be written as 15.5. Now, as in the case of whole numbers, even in decimal numbers, the value of every digit in a decimal number depends on the place that it holds on the place value chart. The value increases as we move from right to left by 10 times, and it decreases when we move from left to right by 10 times. Now here is a place value chart to explain what I just said. Now, in this place value chart, we have the decimal numbers and the place value which starts from hundreds and goes up to the thousands. The first example is 76.48. Since there is nothing in the hundreds place, we leave that place blank. 70, which is 7 in the tens place. In the ones place, we have 6. Once we cross the decimal point, in the tenths place, we have 4, which can be written as 4 by 10. And in the hundredths place, we have 8, which can be written as 8 by 100. Now, I hope you understood that. So here is an exercise to test that out. I'll help you with the first question. Now, in the first question, we need to write these numbers as words. The first question is 632.17, which in words is 632.17. Now, we need to write the following fractions as decimals. Let me help you out with the first question. So, the first question is 16 by 10, which in decimal form is 1.6. We now need to write the following decimal numbers as fractions. So let me help you out with the first question. The first question is 0.85, which in the fraction form is 85 by 100. We all know about the expanded form of decimal numbers. So we need to write the expanded form of the following decimal numbers. Let me help you out with the first question. The first question is 89.42. So, since 8 is in the tens place, we write that as 8 into 10. 9 being in the ones place is 9. 0.42. 4 is written as 4 by 10 and 2 as 2 by 100. We now need to write the expanded form as the decimal form. So the first question says 3 into 100 plus 2 into 10 plus 3 plus 8 by 10 plus 7 by 100 plus 6 by 1000. So that would mean 323.876. We now have to identify the place value of the underlying numbers. I'll help you out with the first question. The first question gives us 24.36. The underlying number here is 6. So, 6 being in the decimal part, we write that as 6 by 100. Comparison of decimals. Now, we compare decimal numbers in the same way that we compare whole numbers. First, we need to change unlike decimals to like decimals. Then, the number with the biggest whole number part is the bigger number, and the number with the least whole number part is the smaller number. Now, in the case where the whole number is the same, we move to the decimal part and check the tenths place. If the tenths place is also the same, we move to the hundredths place and so on. Here is an example to understand that. If we have the numbers 3.16, 3.061 and 3.086, let's put these numbers in the ascending order. So first we need to make the unlike numbers to like numbers. We can see that there are 2 digits after the decimal point for 2 numbers. But for 3.16, there are only 2. So we add a 0 after 6 to make it a like decimal. Now let's compare which number is big. Since the whole number part of the numbers is the same, we move to the tenths part. We see that 3.061 is the least number. Then comes 3.086 and finally 3.160. Addition and subtraction of decimals. Now, we add and subtract decimals in the same way as we do for whole numbers. So here are some points to keep in mind while adding and subtracting decimal numbers. The first is that we need to always convert unlike decimals to like decimal numbers. Second is that you need to make sure that decimal points lie one below the other for all the add-ins. The third point is that for subtraction, always write the smaller decimal number below the bigger decimal number. And the fourth and final point is that the decimal number in the sum or difference should be placed exactly below the numbers that are being added or subtracted. So here is an example. We need to add 24.6 and 0.345. The first step would be to make 24.6 a like number by adding 2 zeros after 6. Once we add 24.600 and 0.345, we get the answer as 24.945. So here is an example for subtraction. We need to subtract 0.652 from 1.2. The first step would be to make 1.2 a like decimal number by adding 2 zeros after 2. After subtracting, we get 0.548. So, I hope you understood that. Here is an exercise to test it out. Let's make the following numbers like decimal numbers from unlike decimal numbers. I'll help you with the first one. So we have 0.7 and 0.53. To make them like numbers, we add a 0 after 7. That makes it 0.70 and 0.53. Now, we need to arrange the following decimal numbers in the ascending order. I'll help you with the first one. The numbers that we have are 0.62, 0.5 and 0.432. We need to first make them like numbers. Hence, we add a 0 after 2 for 0.62 and 2 zeros after 5 in 0.5. Now, when we place them in the ascending order, we write 0.432 first, then 0.500 and in the end, the biggest number 0.620. We now have to add the following decimal numbers. I'll help you with the first question. So, the first question is 7.05 and 8.317. To add these two numbers, we first need to make 7.05 a like number with 8.317. So, we add a 0 after 5, making it 7.050 and 8.317. On adding these numbers, we get the answer as 15.367. We now have to subtract the following decimal numbers. I'll help you with the first question. So for the first question, we have to subtract 63.17 from 92.7. For subtraction, we need to first make both the numbers like decimal numbers. So we add a 0 after 7. On subtracting, we get the answer as 29.53. Let's move on to multiplication of decimals. Multiplication of a decimal with a whole number. Now, we multiply decimal numbers in the same way that we multiply whole numbers. While multiplying decimal numbers, we completely ignore the decimal point. The decimal point in the product is placed from the right after the number of decimal places in the multiplicand. Let me explain that with an example. Here, we are multiplying 1.25 into 34. We multiply these numbers as whole numbers. So, 125 into 34. We completely ignore the decimal point here. On multiplication, we get the answer as 4250. Now, as we can see, the total number of decimal places in the multiplicands is 2. So, 2 numbers from the right, which is before 5, is where we place decimal point. So, the answer is 42.50. Multiplication of a decimal number by 10, 100 and 1000. When we multiply a decimal number by 10, we see that the decimal point moves one place to the right of the decimal number. For example, 5.49 into 10 becomes 54.9. 8.9 into 10 equals to 89.0 and 0.05 into 10 is equal to 0.5. When we multiply a number by 100, the decimal point moves 2 places to the right of the decimal number. For example, 5.81 into 100 is equal to 581. 7.6 into 100 is equal to 760. And 0.09 into 100 is equal to 9. On multiplying a decimal number by 1000, we see that the decimal point moves 3 places to the right of the decimal number. For example, 6.59 into 1000 is equal to 6590. 4.3 into 1000 is equal to 4300. And 5.168 into 1000 is equal to 5,168. Multiplying a decimal number with a decimal number. Now, let's see how to multiply a decimal with a decimal number. We'll do that with the help of an example. We now have to multiply 6.25 into 2.5. We can see that both the numbers are decimal numbers. So, we multiply both the numbers by ignoring the decimal point completely for now. We now have to count the total number of decimal places in the multiplicand and the multiplier. We see that the total number of decimal places is 3. So, when we multiply the numbers 6.25 and 2.5 as 625 into 25, the product is 15,625. Now, since the total number of decimal places is 3, we now add the decimal point 3 places from the right before 6, making the product 15.625. There is also another method to solve this problem. We can convert the decimal form into the fractional form. For example, 6.25 becomes 625 divided by 100 and 2.5 becomes 25 divided by 10. On multiplying these two fractions, we get the same answer. Multiplication of 3 decimal numbers. We multiply 3 decimal numbers in the same way that we multiply 3 whole numbers. We first multiply 2 decimal numbers and then multiply the third decimal number with the product of the first 2. Let me show you with an example. Let's find the product of 2.63 into 1.2 into 0.8. We first multiply 2.63 and 1.2. The answer is 3.156. We now multiply 3.156 with 0.8 and get the final answer as 2.5248. Another method to do the same would be to convert the decimal numbers in their fractional forms and multiplying them again. I hope you understood that. Let's test it out with an exercise. I'll help you with the first question. 4.3 into 1.35. On multiplying, we get the answer as 5,805. We see that the total number of decimal places are 3. So, the final answer is 5.805. We now have to find the product by changing the place of the decimal point. I'll help you with the first question. 4.2 into 10. We know that the decimal point moves one place to the right when multiplied by 10. So the answer is 42. Let's solve the following multiplication problems. 62.3 into 1.7. Let's multiply these numbers ignoring the decimal point. The final answer is 10,597. We can see that the total number of decimal places are 2. So we put the decimal point 2 places from the right in the product. So the final answer is 105.97. Division of decimals. Division of a decimal by a whole number. Let's take an example. A string of length 32.97 meters has to be divided into 7 equal parts. What is the length of each part? To find the answer, we need to divide 32.97 by 7. Let's use the long division method. We can divide the whole number as a part of the decimal. So, 32.97 divided by 7. While writing the quotient, we need to place the decimal point directly above the dividend. So, 7 fours are 28. On subtraction, we get 49. We place the decimal point in the quotient above the dividend. So that is 4 point. 7 into 7 is 49. So 4.7 is what goes in the quotient. On subtraction, we get the answer as 0. We bring down 7, write 1 in the quotient, 7 below 7. On subtraction, we get the remainder as 0. So, 32.97 divided by 7 is equal to 4.71. So, the length of each part is 4.71 meters. Division of a decimal by 10, 100 and 1000. Now, similar to multiplication, when a decimal number is divided by 10, 100 or 1000, the decimal points moves one place to the left instead of the right, respectively, as it is divided by 10, 100 and 1000. Which means it will move one place for 10, 2 for 100 and 3 for 1000. Here are some examples. 5.99 divided by 10 is equal to 0.599. 784.8 divided by 100 is equal to 7.848. And 5.26 divided by 100 is equal to 0.0526. Now I hope you understood that. Let's test it out with an exercise. I'll help you with the first question. Let's solve the following division problems. So we have 63.85 divided by 5. We use the long division method to divide the numbers as whole numbers and place the point in the quotient directly above the dividend. The final answer, the quotient, is equal to 12.77. Now let's solve the following problems by moving the decimal point. 92.3 divided by 10. We know that the decimal point moves one place to the left when divided by 10. So the answer is 9.23. Now, observe the dividend and the quotient carefully to see what the divisor is. We can see that 33.7 divided by blank is equal to 3.37. We can see that the decimal point has moved one place to the left. So the divisor is 10. So let's try and solve some word problems. I'll help you with the first one. Rohit bought 3 bags. The first cost him 328.75 rupees. The second cost him 42.80 rupees and the third 7.25 rupees. How much did he pay in total? As you would have noticed, we need to add the 3 numbers. On addition, we get the answer as 378.80 rupees.